Welcome to the debate. Today, we're tackling a really fundamental challenge in fleet and field operations, the mission phase. This is that precise moment when a physical asset, a vehicle, transitions from being stationary, a known cost center, to moving and actively generating value, but also, actively generating all these variable costs. Organizationally, this moment is so often identified as the weak link.
It is. And that lack of organizational control right at the moment of movement is what transforms the whole financial structure. As long as the vehicles are parked, maintained, the costs are pretty predictable. But the second the keys turn and that mission begins, management's command over real-time spending it often fades. If you don't have that granular visibility and traceability between departure and return, you are not piloting the fleet for profitability. You're just absorbing expenses. It's a process we call blind piloting.
That brings us right to our central question for today. Does the implementation of a rigorous, automated digital framework, one that's specifically designed to eliminate operational improvisation and ensure strict traceability, does that fundamentally optimize field performance? Or does its reliance on a predefined structure actually restrict the necessary flexibility and agility that's just inherent in complex, real-world field reality?
That is the crucial tension, isn't it? That clash between the need for clean, structured data and the reality of messy operations.
I take the position that structuring the mission phase is absolutely essential. It is the only way to transform that dynamic, messy field activity into strategic, usable data. That's what enables real-time piloting and ensures profitability. We have to elevate the mission from a simple activity record to a precise unit of value. Failure to structure this moment means you're just accepting a continuous inherent loss of visibility and, at the end of the day, profitability.
I see why you think that, and I do agree with the core premise. We absolutely must achieve data discipline. However, I'd argue that while the goal is optimization, an overly restrictive, predefined framework carries some pretty significant risks. It risks misinterpreting necessary deviations in the field, deviations that might actually be value-creating, and sacrificing the operational agility you need for specialized complex activities. We have to consider the human factor here. How can you impose a truly rigorous framework without making daily field operations heavier for teams, which, as we know, inevitably leads to high rates of field rejection and, ironically, data inaccuracy?
See, I think the framework is what provides the necessary light, not the burden. The solution is designing a clear digital link between office decisions, the initial plan, and field reality, the execution. The mission module has to operate as the black box of operational activity, not in a surveillance sense, but in a structural one. And this structure is built on a structured reference system that incorporates predefined activities, routes, expected duration, and reference distances. This provides an objective comparison base.
You emphasize that objective comparison base, and I understand why. The idea is that this reference system ensures every kilometer traveled, every hour spent is justified, is optimized. But let's look closer at the implementation. While the system attempts to eliminate improvisation entirely, I believe it only succeeds in channeling it. The reliance on predefined structures like mandatory routes or expected timeframes, it risks overlooking the crucial on-the-ground flexibility that's required for rapidly changing scenarios.
But that data discipline is the pathway to real-time piloting. If we standardize the input, we can analyze the output immediately. We move from reactive management, looking at a fuel bill 3 weeks later, to proactive management, intervening while the mission is still going on.
The core danger, though, arises when field reality deviates from that planned framework. The system can certainly make that deviation visible, sure, but the underlying reason for the deviation, which, again, might be critically value-creating, like prioritizing safety or achieving a quick repair under unexpected constraints, that could be misinterpreted or even penalized simply because it doesn't fit the predefined context. Optimization in the real world requires understanding complexity first, not just standardizing complexity away for the sake of clean data.
Well, that brings us directly to our first key point of disagreement, this idea of channeled improvisation versus operational reality. My position is that if field activity is going to be strategically useful, improvisation must be channeled through that predefined context. The alternative is ending up with, well, a pile of figures that are difficult to interpret rather than usable analyses. The reference system is the necessary friction that forces data discipline and justification.
I appreciate that focus on usable analysis. I really do. But I'm just not convinced that focusing on the reference distance as the main metric of efficiency serves all mission types equally well. Consider a simple, routine delivery run. Sticking precisely to the shortest path is paramount. In that case, sure, the reference distance works perfectly as a performance metric. But now contrast that with a highly complex technical intervention, where the field technician arrives and finds unforeseen infrastructure damage that requires a specialist tool they didn't bring.
And in that scenario, the deviation is precisely what we need to track. The reference system tells us the extent of the unplanned activity, and then the technician records the justification. That allows management to understand if the initial planning failed or if the field reality demanded that detour.
But the technician's operational priority shifts entirely at that moment. They need to solve the problem, retrieve the part, which might mean a 3-hour detour to a secondary depot, and complete the repair safely and quickly. If the system is primarily focused on penalizing or flagging every kilometer deviated from the reference distance, it risks prioritizing compliance with an arbitrary initial plan over genuine, efficient problem-solving in the moment. In this scenario, the deviation created immense value by resolving a complex issue, yet this rigid structure categorizes it primarily as a cost overrun.
But we have to quantify that value. Without the reference system, without that objective comparison base, we have no idea whether that 3-hour detour was justified by the specific unexpected fault, or if it was simply poor planning or inefficient use of time. The structure gives us the ability to ask the analytical question. If we lose the standard, we lose the ability to measure the variance. That is how we get usable KPIs, not just a raw timestamp.
We agree that we must have the comparison base, but we also must ensure that the structure is sophisticated enough to understand that certain deviations are required inputs to the next phase of value creation, not just unwanted outputs. If the field staff perceive the reference system as a compliance tool designed to flag unnecessary movement rather than a diagnostic tool to optimize execution, they will find ways to bypass it, or worse, inaccurately document the information which invalidates the data anyway. The system has to adapt to reality. Reality will not adapt to the system.
Okay, if we've exhausted the issues around movement justification, let's smoothly transition to the challenge of cost accountability. The reliability achieved through automation in expense management. Expense management, I'm talking tolls, fuel, charging costs, ancillary services. This is often where financial information gets truly fragmented and lost. Our source material emphasizes that the solution lies in contextual intelligence logic.
Ah, the intelligent automation layer.
Exactly. Appropriate payment methods and the corresponding expense categories are automatically proposed and linked depending on the mission activity and the geographic context. The efficiency gain is staggering because, fundamentally, the less human intervention there is in data entry, the more reliable the data becomes. The system pre-fills and pre-categorizes based on known mission parameters. This is transformative for financial reconciliation. It just becomes an automated, smooth process. No more stacks of expense reports.
I accept the undeniable value of eliminating manual entry and getting smooth financial reconciliation. Nobody disputes the gains in speed and cleanliness. But I come at it from a different angle when we're talking about conceptual data reliability here. While removing human input increases precision and throughput, it simultaneously removes a really critical point of human validation, a final opportunity for the field user to catch an error.
But we are solving a pervasive problem, human error. Fatigue, rushing, poor handwriting, these introduce massive inaccuracies into manual data entry. Automation just eliminates that noise.
It replaces transcription error with logic error. Field users, relying entirely on these pre-filled fields, they no longer have to actively think about what expense to link or how to allocate it. So if the system's underlying contextual intelligence miscategorizes a non-standard cost event, maybe an emergency refueling with a generic card because the planned station was closed, or an unexpected charge for specialized waste disposal, The system confidently allocates the expense based on outdated or incorrect assumptions.
But that's a hypothetical edge case challenging the entire principle of automation. We are replacing highly variable manual approximation with audible system precision for the vast majority of operations. The benefit of having clean, traceable expense data far outweighs the theoretical risk of a rare contextual miscategorization. And besides, any systemic logic error would be caught during initial audits and corrected system-wide, rather than relying on catching hundreds of individual human errors.
That's a compelling argument, but I would frame it differently. It's not just a theoretical risk. It's a conceptual shift in the definition of reliability. If the mission module is truly the black box recording operational truth, the integrity of that data is paramount. A single error in system logic applied across 500 missions generates 500 confidently precise but factually inaccurate figures. And that systemic error is often much harder to detect than a single obvious manual input mistake. We're relying on the system to be infallible in its contextual awareness, and field reality is rarely that neat.
I would argue that system logic, being centralized and auditable, is ultimately more reliable and accountable than thousands of independent human choices made under pressure. The context for the automation is built upon defining those variables up front. That's the rigor we were talking about earlier.
Financial complexities required by specialized field roles.
Let's move our conversation to the overall architecture, specifically centralization and adaptivity for diverse activities. A core strength of this structured mission module is its deliberate adaptivity. It recognizes that a fleet might cover fundamentally different activities. A simple internal trip is streamlined, minimal data fields, but a highly demanding mission may be one with contractual constraints or strong customer expectations that allows for specific fields, unique references, or supporting documents to dynamically appear.
This feature is key to preventing field rejection. I admit, that flexibility in the user interface is designed to prevent the feeling of unnecessary administrative burden for simple tasks, while ensuring compliance for complex tasks. Delivery, internal travel, while maintaining a single, coherent flow for the centralization of all vehicle data, costs, and documents. That unified flow is what allows the organization to optimize resource usage globally.
That's a strong argument for fleet management efficiency and cost consolidation. But here's the tension. Have you considered whether the requirement for a single coherent flow, while excellent for centralization, fundamentally compromises deep operational insight across those diverse domains?
How so? The data is still captured, because the parameter structure of the black box is engineered, as we discussed, for traceability and justification of kilometers and expenditures. That structural imperative might dilute the value metrics that are necessary for maximal optimization in specialized domains. The benchmark for success in a technical intervention might be entirely focused on first-time fix rate or compliance documentation quality, whereas the benchmark for a simple delivery is purely reference distance adherence and on-time completion.
But the system captures those specific references and allows for the upload of the supporting documents that define the technical intervention success. The centralization doesn't homogenize the data itself. It simply ensures that the core operational movements and costs, the quantifiable unit of value, are tracked uniformly across the fleet. This provides a universal language for performance evaluation that just didn't exist when we had fragmented, siloed systems. The alternative is multiplying specialized tools, which guarantees data fragmentation and incoherence.
I understand the fear of data fragmentation, but when we look at true optimization, we need metrics that are perfectly suited to the activity. If the single flow prioritizes cost justification and distance compliance across the board, the technical team might find their specialized metrics, say detailed notes on specific fault codes, are relegated to secondary, less prominent fields. While the interface is adaptive, the underlying analytical engine, designed for the unified flow, might not prioritize the deeply technical data required to optimize their specific expertise. The question is whether the benefits of centralization outweigh the potential loss of granularity that's necessary for maximizing performance in highly specialized, distinct operational contexts.
I believe the ability to aggregate, compare, and arbitrate resource usage globally across the entire organization, knowing exactly what percentage of my total operational movement is spent on internal transfers versus profitable external interventions, that far outweighs the difficulty of tailoring specialized analysis post-collection. We are moving from ignorance to insight. The structure is the necessary foundation.
The goal isn't ignorance, but maximal suitability. We're balancing the efficiency gains from a unified structure against the potential sacrifice of the deep operational insight that specialized analysis requires.
As we conclude, the core message I want to reiterate is this. The mission is the crucial moment where assets create value and simultaneously where they generate the most variable costs. Not structuring this moment is accepting a permanent loss of visibility and control. The automated, structured module provides the necessary transformation from merely absorbing expenses to actively piloting performance by demanding traceable, justifiable data for every kilometer moved.
And I absolutely affirm that robust data discipline is fundamental for performance improvement, and therefore, digital structuring of the mission is a necessary evolution. However, I reassert the caution that true optimization requires us to understand and value the necessary deviation that field expertise generates. Rigid frameworks, if implemented without sufficient operational context awareness, risk obscuring this essential complexity or categorizing necessary field agility merely as unjustified deviation or a system error.
This discussion, I think, really illuminates the fundamental trade-off introduced by converting dynamic field movement into structured, usable data. The undeniable, substantial gains of structured control and systemic efficiency versus the potential sacrifice of granular operational flexibility and the accurate interpretation of necessary, value-creating exceptions.
And we're in strong agreement that the mission represents the ultimate point of convergence for value creation and cost generation. This just underscores the necessity of continuous, nuanced analysis to ensure that the tools we create to manage complexity don't in fact punish legitimate operational reality.
The listener is left to weigh the benefits of moving towards standardized, real-time piloting through unified digital frameworks against the vital need to preserve operational agility in highly varied, complex contexts. Thank you for this rigorous exchange.
A pleasure, as always.